Welcome to the science video, Combined Science 5129, syllabus 2021 to 2023, topic motion, force and energy, subtopic elastic part 4. So there are 3 learning objectives in this subtopic. We've already finished learning objective number 1 and also learning objective number 2. In this video, we'll be focusing on the learning objective number 3. In this learning objective, students should be able to sketch a graph, plot a graph, interpret a graph, and also describe experimental procedure for load extension graph. In the previous video, we have already gone through for the experimental procedure. In this video, we'll be focusing on the graph. First of all, what is the differences between sketching and plotting a load extension graph? To sketch a graph, you need to draw the y and x axis and make sure to label the axis, and then from 0 you draw a diagonal line from 0 and draw diagonally upwards. For plotting a graph, you need to make the x and y axis. However, this time you need to mark all the points. Here, you have to do all the markings. And then you have to plot all the data given to you, like so. Only then you can start drawing a line from 0 and then passing through all plotted points. So that's the difference between a sketch and a plotted graph. Let's try an example here. A student adds different loads to the end of a spring. She finds the extension in each case and plots a graph of extension against load, which is the correct graph. As you can see here, you are given a sketch of the graph. Graph A, B, C, and D. The answer is graph D. Plotting graph requires data from an experiment. So usually you will be given data for you to plot a graph. This is an example of data. Sometimes in questions, before you plot a graph, they will ask you to fill in all the blanks in the table. So here, you need to find the original length of the spring, and in the table here you need to find the new length of the spring and also the extension of the spring. To answer this question, we have to go back to the previous formula that we have learned. We have learned extension is equal to new length minus original length. So we have to play around with this formula. So if you want to find the formula for original length, you need to write original length is equal to new length minus extension. And then if you want to find new length is equal to original length minus, you bring forward will become plus, and extension you bring forward to the other side. New length is equal to original length plus extension. So here, original length is equal to new length minus extension. So the new length here is 12 centimeter. So we put that 12 centimeter minus, and the extension here is 2 centimeter. So we put 2 centimeter. 12 minus 2 will give us 10 centimeter. Next is finding new length for this blank here. So we are given 4 centimeter extension and also original length that we have already calculated. So going back to the formula to find length. To find new length, we use new length equal to original length plus extension. New length equal to original length plus extension. The original length is 10 centimeter and the extension given is 4. So the answer 10 plus 4 gives us 14. The same thing here, we use the same formula. Original length is 10 and the extension given here is 6. So 10 plus 6 will give us 16. And the last blank here, which is to find extension. Extension is equal to new length minus original length. So the new length here given is 16 centimeter and the original length is 10. So 16 minus 10 will give us 6 centimeter. So that's how you complete the given table for recorded data. So how do we plot a graph from the given data? So let's say this is an example of a given data. So to plot the graph, make sure you label the x-axis and y-axis as load and extension, and you mark the points. Okay, now we look at the first row here. We only need data for load and extension, so we ignore length. 0, 0. So on the graph, it will be here at 0. So we put a cross there. So that is the plot. That is our first plot. And then going to the second row here, ignoring the length, 1 Newton, 2 centimeter. So we go here 1 Newton, and then we go here 2 centimeter. So we plot there another plot. So that is for the second row. For the third row, 2 Newton, 4 centimeter. So we go to 2 Newton here, and then we go to 4 centimeter. Then we plot. And the last row, 2.5 Newton, 5 centimeter. So we go to 2.5 Newton, we go here 2.5 Newton, and then we go to the 5 centimeter, and then we plot again. After we have plotted all the points, what we need to do is to make a straight line that goes through all the plotted points. It starts from 0. So we are finished now. We have already plotted a graph. Next is interpreting a graph. So this is an example of a load extension graph. As you can see here, if you see a slanted line, it means that the load and the extension is proportional. Spring will return to its original form when force is removed. However, as you see here, there's a limit. After the limit of proportionality, spring will not return to its original length when force is removed. Interpreting a graph, example on application. Okay, so you have a graph here. The question, find the load on the spring when it has an extension of 4 cm. So make sure to look at the extension at 4 cm. At 4 cm, we'll see that the load is 2. Let's try another example. Find the load on the spring when it has an extension of 5 cm. Now you look at 5 cm. After number 4, here is number 5. So at 5 cm, load is 2.5 Newton. So the answer is 2.5 Newton. Another example, find the extension on the spring when it has a load of 4 Newton. So this time we look at the load instead of the extension. So the load here is 4. So at 4, extension will be 8 cm. Let's try another example. Find the extension on the spring when it has a load of 10 Newton. So 10 Newton is here. So the extension is 12. So the answer is 12 cm. So with that, we have finished all the learning objective for elastic deformation. Bye-bye.